Okay, so this is if I is equal to 4. So what we want to do 0, 1, 2, 3, 4. We want to drop 49, which we clearly don't. We drop 46 instead. So should this not be -1? But we do successfully drop 46, it looks like. So we go 45, 42, 45, and then we drop 46. Then we have 49, 49, 53. So that looks successful, other than the fact we dropped the wrong thing. Did we drop the wrong thing? No. This should be 2. So if we want to drop 2, then we want to take 0 and 1. So if we want to drop index 2, we want to take 0 and 1. So I think that's correct, but this is clearly wrong. I guess I just misunderstood the semantics of that. 347? Fuck, I don't know, man. Now it's too low. Alright, so what I'm going to do is here I'm going to define missing 1. Yeah, I'm just missing, and at some point we'll need to make that depend on an amount. So cons missing report I with remain. Okay, and we'll take that, we'll put that up there. Okay. And we don't need that. Okay. All right. So what we want to know is we want to know missing L0, missing L1, 2, 3, 4, whoops, 5, 6, and I think that should crash. Unbound variable report. Yep, I agree. It should be ls. It should be ls. Okay. Yes, and we actually skip 0. Though I don't think we should. So I guess like if equals 0 I, then what we want to do differently is we just want to go cdr ls, else we want to do something. Oh, I see. Yeah, so from here until 99, can you replace missing with, no, can you just replace missing with display? Illegal address combination. Apparently not. Oh, I maybe didn't do the replace. Yeah, search for missing and replace it with display. There we go. Oh. Okay, let's try again. From here to 99, search for and replace that with, there we go, that's better. And then we'll do this. And get rid of that. Okay, cool. So that did nothing. Brilliant. Not what I wanted at all. Jesus fucking Christ. Okay, so I want to take... Yeah. What are these? What has this done? It's just removed the first 40... So this one's removed the first 45. This one's removed the first 45. This one's removed the 42. This one's removed, I think, the second 45. This one's removed the 46. This one's removed the first 49. This one's removed the second 49. So most of them are actually correct. That's interesting. I didn't expect that. But 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. So that... So we're off by 1. If you want to remove 1, yeah, you actually just want to take 1. That's actually correct. I don't know if that part's correct. Okay, now it's doing nothing. Okay. Okay, that was dumb. I don't feel proud at all. I feel ashamed. I feel disgusted. Yeah. Okay, what have we learned, if anything? Okay, so we learned that Scheme doesn't have shit. We wrote a bunch of really terrible ways of doing things that traverse lists way too many times, instead of doing better ways. What else do we learn? So Scheme doesn't have anything to manipulate lists despite being a list-oriented language. That's fun. I don't know. I think that's the main thing we learned. I think the main thing we learned today is you just got to write it yourself. Scheme does not have it. If you want it, it doesn't exist. Sorry. Yeah. At some point, we're going to have to, because Advent of Code will use these a lot. Like sliding, I've been told, is used quite a lot in Advent of Code. So we'll need to rewrite this to not suck. Because right now we... yeah, we do this in a loop. So this is what, like n squared? And it definitely doesn't need to be n squared. So we'll have to rewrite this at some point. We'll probably need this, but we'll need to parameterize it of how many we're going to cut from the middle of the list. This implementation is kind of okay. The only problem is that this goes through twice, which we don't need to do. We can just go through once. In fact, we don't even need to go through the whole thing once, because of the way lists work in Scheme. You don't even need to go to the whole thing. But yeah, okay. I'm not proud of how we did, but we got it done. And that's all for now.